So in the last class, uh, we had a confusion about why this tau zz was minus 2 mu dou vz by dou x, right? So how this two factor comes here? Okay, so let me clear this, how this 2 has come. Okay, so you have to use this formula. Okay, this already we discussed in the previous lecture. Okay, prior to the falling film problem. Okay, so whenever you want to calculate shear stress, you have to follow this formula. Okay, fine. So generally you have to take this part only. You can ignore this part. Okay, so you only consider this part in general for all the problems we're going to discuss in this course. Okay, fine. So this is the formula. So if you remember, in the falling film problem, we had the velocity profile was function of x, right? It was not function of z, because because we were studying steady state. Okay, this comes from steady state, or fully developed, we can say. Fully developed flow. So there is no dependence of the flow profile with time. So already the equilibrium, we can say equilibrium has achieved. Okay, full developed flow. So it is not function of time, but it was function. This was the following problem. The velocity was flowing this direction. It was a function of this perpendicular direction x. Okay, so in that we encountered this one, right? So why there is 2 here? So if you use this equation, now just put the instead of I and j, z. So what you'll get, tau z is equal to minus mu dou v. So this one first, okay, dou vz, then this one dou z, plus again, even if you interchange it, this is just interchanging indices. So even if you interchange it, it will be the same because both indices are same, right? So what you will give, this plus this is equal to minus 2 mu, right? Sorry, this was z. Okay, right? So that's how it came. Okay, now I will tell you the different case. You might ask why tau xz is equal to minus mu dou vz by dou x, right? This is the formula. But let's get this same value with this formula. Okay, so put, instead of I, just put x, instead of j, z. So just try replacing the indices. So minus mu dou v, j was z, then dou x plus dou vx dou z, right? So in that falling film problem, I explicitly told you that there is no flow in y direction, there is no flow in x direction. So this becomes 0, right? Vx is 0, so only left with this. So that's why we use this one. Okay, I hope you have got this formula. Okay, but again this will also be 0 because the velocity, vz did not depend upon the z direction, it only depend upon the perpendicular direction x. Anyway, I want to tell you how this 2 came. Okay, hope you have understood it. Okay, thank you.